Hello, how are you? Welcome to a new training module on logistics and transportation. This time, we will be referring to the use of the Logistic Regression model for predicting drowsiness, designed for drivers in the freight transportation industry. Federal freight transport represents one of the highest risks for experiencing drowsiness due to the specific work conditions to which our drivers are subject, mainly referring to long periods of uninterrupted driving, which makes it even more variable when it comes to fatigue and drowsiness. This study focuses on the freight transport sector to adequately address the needs of the sector in terms of fatigue, which is one of the main factors contributing to accidents. Regarding the statistical model, this work is based on logistic regression for predicting drowsiness using variables related to physiology, driving behavior, and sleep patterns of drivers in federal freight transport. The choice of model for this research is based on combining logistic regression models with physiological variables, driving behavior, and working hours, obtained in a non-invasive manner through questionnaires. For this, we refer to variables like stop time, the Epworth sleepiness scale, morningness, and eveningness. Let's now talk about logistic regression. Logistic regression is a statistical model used when the variable we want to predict has two options. But how does it work? Unlike linear regression, which predicts continuous values such as weight, height, etc., logistic regression predicts the probability of something happening. So, what do the elements in the question represent? Let's talk about the probability of the event occurring, whether y equals having or not having fatigue. x1, x2, and up to xn represent the influencing factors, for example, stop time, score, or other types of tests, sleep hours. The intercept represents the value when all variables are 0. b1, b2, and up to vn are coefficients that represent the variables and the influence each has within the model. E is a number used in exponential functions and often represents the error. Now the important question: what is logistic regression used for? Logistic regression is primarily used to model and predict probabilities, meaning events that can have two possible outcomes, such as yes or no, true or false, or success and failure. It is used in a variety of fields, including transportation, logistics, medicine, marketing, social science, etc. Logistic regression can be applied in any area of study. In our case, for example, predicting whether freight transport demand will be high or low on a particular route or season. Independent variables include time of day, market conditions, weather, fuel conditions, etc. The dependent variable in this case will be whether work demand is high or not. Let's start by looking at the sample size. These questionnaires were applied to 450 federal freight transport drivers, which far exceeds the reliability level specified in the sample size formula for applying this type of questionnaire. The first questionnaire is called Stop Bank. It consists of 8 simple questions related to the driver's behavior and physiology. This questionnaire aims to detect the risk of obstructive sleep apnea. Here, you can see the questions that are always answered dichotomously, yes or no. If the stop bank test applied to the population of truck drivers, 25.81% of drivers were found to be at high risk. This refers to the variable indicated. For example, the factor that most affects whether apnea is present is snoring. This is highlighted in the graph showing one of the factors being studied. Age refers to whether the driver is male or female, which also represents another percentage, reaching over 25% of the total histogram. It is important to note that combinations of variables can have a negative effect on sleep apnea. For example, in this case, we highlight BCD, where B stands for tiredness. C indicates that the driver was observed to stop breathing while sleeping, which is common and dangerous. And D refers to high blood pressure, a very common situation in freight transport that could be a major cause of many accidents on our roads. The second questionnaire we apply is a stop bank with a variation. We ask 8 questions, all focused on driving and the driver's rest. These questions were also answered dichotomously, yes or no. These questions are related to the driver's work. Norm 87 provides guidelines for regulating driving and resting times for federal and private freight transport drivers to reduce the incidence of accidents due to fatigue. The result from these 450 workers clearly show that it is approximately the line at which a driver should rest while working. As you can see, most of them severely fail to comply with the guidelines of Norm 87. Anything from 4.5 or 5 hours to 18 hours becomes increasingly problematic, raising the risk of accidents. For example, you can observe that the dispersion in compliance with Norm 87 is inconsistent. On one side, we have the compliance line, but on the other, we have those who do not comply and those who do. From this, it is also evident that it becomes CK, meaning there is no compliance, no regulation requiring adherence to rest hours, thus failing to reduce accidents on our roads. The Epworth questionnaire consists of 8 questions related to the user's tendency to fall asleep. This helps determine whether they suffer from excessive daytime drowsiness. As shown in the histogram, all drivers who answer and were part of this dataset represent a danger when it comes to driving after meals. Even more so, those who operate for up to 20 hours despite the problem. As you can see, only 14% of drivers in Mexican transportation units respect the standards and their physical condition. Most do not, and this could be one of the main causes of accidents. For example, if you want to improve the driving behavior in your company, a single variable will represent a significant change. Here, using the statistical method, one variable could result in a major change in the competitiveness of your company. In this case, we're asking whether increasing the level of this variable will significantly increase the possibility of an accident happening. Why? Because the driver is operating in evening or nighttime conditions when their body is not accustomed to do it. Now, let's discuss the morningness, eveningness questionnaire, also known as a chronotype. It consists of 19 factors aimed at determining whether the individual is more morning-oriented or evening-oriented. Here, we can observe that most drivers are evening types. This means that the more their work hours deviate from their typical schedule, their accident risk significantly increases. Similarly, the more they respect their work hours, the lower their accident risk. But as you can see, it is much more likely that drivers operate many more continuous hours and at different times, especially in the night time, which starts around here. This means that over 50% of our Mexican fleet operates at night. In this Pareto chart, we can clearly see that 82% and 4.7%, almost 90% of our fleet operates after evening hours. Very few operate in moderate or early morning hours. We are talking about only 12%. Changing the culture of our supply chains is certainly difficult. However, we can clearly see through these questionnaires how it affects and contributes to fatigue, which in turn impacts accident rates. I sincerely hope that the data and examples presented in this clip will be useful in increasing your company's competitiveness. See you soon.